Hello, in this video we are going to learn how to solve this Oxford Maths entrance exam question. We are asked to solve for x in the exponent value of x equal to x to the power of 2. Now if you are given this question to find the value of x, what are you going to do? Now let's go straight to solving this question. Remember that if we want to render the right hand side to be equal to x, one simple thing we need to do is to multiply both sides by the power of 1 divided by 2. Fine. Now once we multiply both sides by the power of 1 divided by 2, we are going to have this expression to now become the exponent of x multiplied by 1 divided by 2, and this will be equal to x to the power of 2 multiplying 1 divided by 2. Now according to the law of indices, the exponents will have to multiply. Now you recall that law of indices. We are going to have this expression to now give me the exponent of x divided by 2, right? And that will be equal to x to the power of 2 multiplied by 1 divided by 2. Great. Now 2 will have to cancel out 2 and will be left with 1. Now from that expression, I can simply have the exponent of the power of x divided by 2 to be equal to x. Now at this point, what will you do? Now at this point, we have to simplify further. And for us to simplify further, recall we are asked to find the value of x. But the value of x cannot be equal to exponent of x divided by 2. So what do? Let's see if we divide both sides by x, we can be able to get a good solution. Now if I divide both sides by x, I'll have the exponent of the power of x divided by 2 divided by x, and this will be equal to x divided by x. From this expression, x will have to cancel out x, and we'll have that expression to be equal to 1. So that expression is going to give us the exponent value of x divided by 2 divided by x, and this will be equal to 1. Great. So what are we going to do from here? At this point, I'm going to simplify. If I simplify this in the next step, I'm going to have that expression now to give me 1 divided by x multiplying the exponent value of x divided by 2, and this will be equal to 1. I didn't change anything, I just removed the fractional value 1 divided by x. So at this point, what do I need to do? I want to simplify this further, and to simplify this further such that I can easily simplify or expand this, I need to multiply both sides by the power of -1. Now if I multiply both sides by the power of -1, I'm still going to have the right hand side to give me the same expression. So this whole thing will give me the value of 1 divided by x multiplying the exponent value of x divided by 2, and all of this will be multiplying -1, while the right hand side will be 1 to the power of -1. 1 to the power of -1 is going to give me 1 divided by 1, and as such it will still be equal to 1, right? So that is going to give me equal to 1. Now from this other side, I'm going to expand, and if I expand that, I will separate this to give me the value of 1 divided by x all to the power of -1 multiply the value of the exponent value of x divided by 2, and all of this will be with the power of -1. Now from this point, what will you do? Now recall that if you have this 1 divided by n, it can simply be equal to n to the power of negative 1, right? So if 1 divided by x give me x to the power of negative 1. Negative 1 multiplying negative what? 1. Minus times minus will give me 1. So that value will simply give me x. So we'll have x here multiplying, and that will multiply the external factor. The external index will multiply this, and that will give me the exponent of negative x divided by 2, and this will be equal to 1. Great. Now in the next step, what will you do? Now at this point, I want to utilize a very good law, but before I utilize that law, I want to make this expression well defined. And to make this expression well defined, I want to apply the Lambert W function. But before I apply the Lambert W function, I have to name this expression such that it can suit the Lambert W function. As you strive to use the Lambert W function, don't forget to give this video a thumbs up if you really appreciate what you are doing. Share with friends and colleagues, and remember to subscribe to my channel for more simplified maths content. And don't forget to give us a super thanks if you truly appreciate all what we are doing in this channel. Now, for us to make this expression look like a Lambert W function, we need to multiply all through by negative half. Now, if I multiply all through by negative half, I'm going to have that expression seriously expanded. Now, if I multiply all through by negative half, I'll have that expression to become all of this x multiplied by the expression x divided by 2, and all of these will be multiplied. Remember, I said they will be multiplied by negative half, right? And this will be equal to 1 multiply negative 1 divided by 2. Great. Now in this expression, we are going to expand this. This is going to now give me negative half times everything in that bracket is going to be me negative x divided by 2, right? Because x times negative 1, and this will be multiplying the exponent of negative x divided by 2. Now that, can you see what I'm saying? And this will be equal to negative 1 divided by 2. And if you look at that expression very well, you will come to see that we have mended that expression to look like the Lambert expression. And what does the Lambert expression say? The Lambert expression says that if I am given the Lambert of a given function a multiplied by the exponent of a, or the exponent of a, right? This will simply give me equal to a. Now from this expression, my a is negative 1x divided by 2, right? Good. If that gives me this solution, that means I'm in the right what? I'm in the right track. So that expression will simply, if I look for the Lambert of this, I'm going to, if I simplify this by looking for the Lambert of this, I'm going to have that expression to simply give me negative x divided by 2. That is on this side, right? While on the right hand side will give me the Lambert of negative half, right? Great. So if I reduce that expression, or I reduce that expression very well by multiplying both sides by negative 2 so as to clear the fraction or the denominator. If I multiply both sides by negative 2, I'm going to have this to become negative 2 multiplying negative x divided by 2, right? And this will be giving me the Lambert of negative 1 divided by 2 multiplying negative 2. Now from this expression, 2 will have to cancel out 2. Negative, this will become 1, right? Negative 1 times negative x will simply give me my x to be equal to, this multiplying this will give me negative 2 Lambert multiplying negative 1 divided by 2, right? Great. And that is exactly what that expression is going to give me. Now if I simplify this expression, I'll have my solution to simply be equal to x equal to negative 2 the Lambert of negative 1 divided by 2, and that is the solution to this mass expression given to us up there. Now if you look at this solution very well, you see how we utilize the Lambert W function in solving this mass question. Don't forget to give this video a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified math content. Thanks so much for watching, and bye bye for now.